Today we're going to take a look at the day 4 notes and we'll be reviewing our first 3 days of vectors. So the first thing we're going to take a look at is what is a vector? And you guys might remember this from looking at the boat investigation. A vector has two components here. It has both some sort of size and direction. So miles per hour would not be a vector. We'd have to have the direction. It's going 60 miles per hour east or 60 miles per hour north. So the first thing we're asked to do is sketch a vector representing 50 newtons and 50 newtons of force on a bearing of 120. So if here is our x-axis, 120 would be here. So here's our angle is 120 degrees. And then I'm going to label this that's 50 newtons. Now this next thing is a review of what you did yesterday. The length of the arrow represents the magnitude and size, and the arrow indicates the direction. So in component form, you might see this as AB with a little vector. And in component form, well, if we're going from A to B, 1, 2, 3, 4, 1, 2, 3, so we'd have our x component as 4, 3. Now if we were going to say this vector B to A, we have to think of the direction here. So we go backwards 3 and down 4. And my bad, I messed these up. We need to do the x part first. The x goes on top. So that would be 3, 4. So in component form, it's always x, y. Sometimes if this had a little a there, you might also see it as A 3, 4 with or without the line on top, but this would be in bold there, and it's hard to make it bold in writing there. Now the notation for magnitude, those are our absolute values brackets that you'll see it looks like that. So the absolute value, well, what's 4 squared plus 3 squared? Well, we know that's 3, 4, 5 triangle, so the length would be 5. Now adding and subtracting vectors. So if we have Q, 1, 4, and we're subtracting P, 3, negative 2. So this is like saying we have a vector, we go over 1 and up 4. And then we're subtracting, so we're going backwards 3 and, or excuse me, so oops, there's our vector right there. But then what's happening, we're going the other way, so we have 3 and negative 2. So like where would our vector actually be there? So we just subtract our x components. 1 minus 3, so negative 2. 4 minus negative 2 is 6. So what this is saying, this drawing did not turn out the greatest here, but we have, so over 1 up 4. But now we're going to go backwards 3 and then minus negative 2, which is really plus. So really then the component, if we were to draw from one vector to the other, it's saying this is backwards 2 and up 6. But we just add or subtract the x's and the y's. So P, whoops, this one, let's see, P is 3, negative 2, minus 1, 4, plus negative 2, negative 5. So we take our x's. So 3 minus 1 is 2 plus negative 2. So that would be 0 for our x. And then if we do our y here, we have negative 2 minus 4. So negative 6 plus negative 5 is negative 11. When you're multiplying by 3, we call this by a scalar, you just multiply both the x and y by that. So we have 3, 12. It's basically saying, so we have 3, 1, 4 vectors, so over 1, up 4, over 1, up 4, over 1, up 4. what is that vector? Well, we really are going over 3 and up 12. So we have p minus 2r. So p minus, and if I double r, -4, -10. So again, now we just take those x parts here. So 3 minus -4, well, that would be 1. -2 minus -10, so plus 10, so we have 1/8. And then the last thing, again, this stands for the magnitude of r. So r, we go backwards 2 and down 5. So that Pythagorean theorem, -2 squared plus -5 squared equals c squared. So 4 and 25, so the square root of 29. So the next one that we're going to take a look at here, let's see, if p is -1, 2, and q is 3, 1, find pq and the magnitude. So these are coordinates here. So if we were to graph this, -1, 2, and 3, 1, and we're going from p to q. Well, how do we get from p to q? Well, we go over and down. So -1 to 3. So we're going over 4, 2 to 1, and down 1. So here's our vector PQ. If we would have said Q to P going the other way, we would say we go backwards 4 and up 1. And then it says the magnitude. Well, 4 squared plus -1 squared equals c squared. So we have the square root of 17. This next one, use vectors to show that this is a parallelogram. So -2, 1, 2, 3, 4, 5. -2, 5. So there's A. 1, 2, 3, 1. There's B. 2, -1. C. -3, 3. D. Well, we know to be parallelograms, opposite sides have to be parallel. Well, let's see. So DA, how do we get from D to A? -3, and if we look there to -2, so we go up 1. 3 to 5, we go up 2. And if D to A, it has to be parallel to C to B. So C to B, C to B, once again, we go up 1. And then if we take these other coordinates here, let's see, -1 to 1, up 2. So those are parallel, but then we'd also need to show that AB is parallel to DC. And if we do that, A to B, -2 to 3, so we're going over 5, 5 to 1, down 4. D to C, so again, D to C, -3 to 2. Well, that's over 5. And then what are we doing? Let's see if we look at this other one. We got 3 to -1, down 4. So those are the same. So it is a parallelogram. So two vectors are parallel if one is a scalar of the other. For example, if we had 5, 8, 10, 16, this is a scalar. You multiply by 2. A position vector means it's from the origin. So if I had the position vector 3, 2, and I was to graph that, we'd start from the origin over 3 and up 2. And there's our vector. And a unit vector is any vector that's 1 unit long. So we say I is the unit vector, 1, 0, and j is the unit vector, 0, 1. So when we start looking at this, it says write in unit vector form. 3, 4, that's another way of saying the vector 3, 4. So this is saying that we go over 3 and up 4. So in our unit vectors, if it's 1 unit long, we go over 3, and each one of these is an I, so we go 3I, 1, 2, 3, 4, so plus 4j's. So it's just saying if they're 1 unit long. So 2I minus 5j's, so that means we go over 2 and down 5, so 2, negative 5, so 2, negative 5. Find k given that it's a unit vector. Again, unit vector means 1 unit long. So according to this, here's our x and our y. So we go backwards negative 1/3, and we could go up or down, who knows, but we know that distance, the actual vector, is 1. So if we do the Pythagorean theorem, negative 1/3 squared plus k squared has to be 1 squared. So we have 1/9 plus k squared has to equal 1. Well, so k squared equals 8/9. Then we can take the square root. So k equals square root the top and bottom, 8 over 9. Oops, over, that should be 3. And then we know we square root 8. So that's a square root of 4 times a square root of 2 over 3. So 2 square root of 2 over 3. Now, all properties of 2D vectors is the same as 3D. So if we're working in 3 dimensions, it's the same. So vector A to B. So A, we have 0, 2, 0. B, 3, 0, 2. So vector from A to B, how do we get from A to B? 0 to 3 is 3. 2 to 0 is negative 2. 0 to 2 is positive 2. And then we have to find B to C, negative 1, 2, 3. So 3 to negative 1, so BC. 3 to negative 1, so negative 4. 0 to 2 is 2. 2 to 3 is 1. And the magnitude of AB. So once again, the magnitude, you'll see with those absolute values. So we just do 3 squared plus negative 2 squared plus 2 squared. So 9 plus 4 plus 4, well, that's 17. So we have the square root of 17.